Could you build a business that's better for our planet? That's what I have set out to answer. Hi, I'm Marco Pimentel, marketing expert and entrepreneur, and host of the podcast Someone Like You. I've become fascinated in finding creative climate solutions in business, and on the podcast, I break down how founders and CEOs are building climate-friendly business solutions that are opportunities for growth while being better for the planet.
3/4 of industrial emissions literally comes from burning fossil fuels to create heat to drive the processes that manufacture everything we use, eat, consume, and utilize in the world today. And half of that industrial heat is in the form of steam.
Steam is still a big deal when it comes to industry. It stands for about 8% of the global primary energy use, generating over 2 gigatonnes of greenhouse gas emissions per year. Facing that scenario, innovators like Addison Sark see this as an opportunity and a need for change and emerge as champions of sustainability. Addison's journey fuels his passion for decarbonizing industry, and in this episode, he unveils the transformative power of Boiler 2.0, a pioneering steam generation tool harnessing air heat, boasting unmatched efficiency and zero carbon emissions. He also speaks about founding his company, AtmosZero, aiming to redefine the traditional boiler room for a decarbonized future, and how the electrified Boiler 2.0 stands as a beacon of sustainable innovation in the steam-centric world. Addison uncovers the mechanics behind the technology and how it presents a cost-effective, scalable solution delivering consistent carbon-neutral steam at temperatures surpassing 200 degrees Celsius. AtmosZero's Boiler 2.0 integrates seamlessly, accommodating variable, intermittent, or constant streams, enhancing plant efficiency and paving the way towards a sustainable zero-carbon industry landscape. Here is our conversation. Addison, welcome to the show.
Great to be here.
So I kind of want to get just started with background. And, we typically talk to entrepreneurs and founders and understand was there any correlation to, what you're doing at AtmosZero and climate and sustainability in your background?
Yeah, it's a great question. And it kind of makes me start thinking back really a long ways. I grew up on a farm in eastern Iowa, farm boy, and I was surrounded by the impacts of climate change early on, recognizing that there was kind of every growing season was starting to change. And really, when I was a child, I wanted to become part of solving climate change. So that brought me on a long journey. I went to the University of Iowa, where I got involved with environmental work as the student body vice president, was helped to create the first campus-wide renewable energy and efficiency goals, kind of the first energy policy at the university. And they've come a long ways in achieving that. But that brought me to grad school at MIT, where I did my PhD in mechanical engineering. And I really started to work on the hairy problems of actually developing the technologies that we need to be able to hit net zero goals by mid-century, really hit the thresholds required to solve climate change. That's brought me on a professional journey that's readied me to become an entrepreneur in this space. After my PhD, I worked at an agency in Washington, D.C., in the Department of Energy called ARPA-E, Advanced Research Projects Agency Energy, where I was developing technology, investing in technologies around industrial decarbonization before we even called it that. Manufacturing efficiency, thermal energy systems, energy water nexus challenges, focusing on investing in things that we haven't really innovated in for 50 years. The heat exchanger, we use the same designs we've used for a long time. After that, I worked at a think tank where I took kind of that experience of investing in early stage technology, but started to focus on the big levers that really matter for decarbonization, for achieving climate goals, which is focusing on moving the billions and trillions of dollars through Congress that were necessary to help scale technology. So that was a really interesting experience to learn about how policy will not only be impacted by technology options we have, but also how policy impacts the technologies we're trying to scale to solve this problem. Along the way, I got really interested in industrial heat, really looking at what turns out to be the most important piece of industrial decarbonization is dealing with how we generate heat. 3/4 of industrial emissions literally comes from burning fossil fuels to create heat to drive the processes that manufacture everything we use, eat, consume, and utilize in the world today. And half of that industrial heat is in the form of steam. So that's what led to what I'm doing today. I recognized a big opportunity to develop a scalable solution to decarbonize steam boilers, where the is the technology that really drove the Industrial Revolution and hasn't been innovated on since the 1860s, really, when Babcock and Wilcox introduced the packaged steam boiler. We see an opportunity now to cost effectively electrify that. So it's been a winding path to want to do this, but where I am now is excited about what entrepreneurship can be to be able to drive the hardware solutions we need to solve climate change.
And to go back to this comment of I was a farm boy and I wanted to, I knew I wanted to be in climate. What was it that you learned about climate at a young age that led you to, to create an energy policy at your school to then go on to further your education? Like, was it just understanding that, the weather has an impact on, your family's yield, or what was it that you had noticed or learned along that way at a young age to kind of cement this pathway for yourself?
Yeah, what I saw early on was, to be honest, to some degree, what didn't work. So obviously, we started to see kind of hotter and drier summers, more and more droughts, more challenges for growth. Obviously, a lot of that has been resolved to some degree by innovation in agriculture. We have more hardy varietals that have come out of agricultural innovation that have to some degree masked the challenges. But what I saw was policy and technology interventions that were not exactly climate solutions. When you look at renewable fuel standards, for example, blending requirements for ethanol into gasoline, these things actually require a lot more land and a lot more energy to deliver a replacement for gasoline than just putting solar cells out in the fields would be, and maybe losing a little bit of productive land, or to be smart about doing agricultural integration of photovoltaics and being able to do both simultaneously, or wind. The challenge we saw when you look at things like the energy policy work that was done in the early 2000s was to push us towards solutions that were not going to scale to net zero. And so, it was really looking at what were the tools that I saw around myself, and, learning about welding at a young age, learning how to build solutions is what drove me to want to do something mechanical, wanting to do something in hardware. And that's exactly what we do today at AtmosZero. We're now based in Fort Collins, Colorado. We have a lot of former farmers, former oil and gas people working with us, people with real hardware skills that are now applying it to the energy transition. But it really is a thread that I've kind of followed for a long time.
So, coming out of school, coming out of MIT, you have this idea after working in the think tank to get into steam boilers and to kind of possibly disrupt this industry. How did you go about this? Was this done did you get some kind of early funding and saying, like, this is an area that's worth disrupting? It's a huge market and it's not being addressed in the proper way, and there's probably new technology that we can implement here that can be dropped into a commercial setting? Like, what was those kind of first initial kind of like idea to, okay, now, now let's actually let's start to build out our first prototype?
Yeah, for sure. So obviously, what I decided to do is I made a list of all the sexiest problems to solve, and then I crossed them all out, and I focused on the boiler room. Right? Maybe that's something there. There's a truism there, which is, I started from data. I started from what are the things that are being overlooked, but what are the things that are truly impactful. And when you look broadly at a lot of investment that happens in the climate space, you see a lot of vanity investment. You see a lot of investments on the next hot thing, even though a lot of people in hardware will make fun of maybe like the traditional tech, crypto world, and AI for being the next hot thing. We see that in climate too.
Yeah,
You know,
yeah.
I really have been focused on putting the blinders on and focusing on what is the most impactful thing we can do profitably. And that's what we saw. And the insight was in the boiler room. They are ubiquitous. Boilers are a common product that delivers process heat and heating for buildings from 120 to 225 Celsius. It's a common, scalable, modular product. And we needed to make something that would do the same in an electrified way that could be cost competitive. Now, what it really means is we're building a new boiler. That is a traditional manufacturing approach. We're doing it more based on industrial HVAC technology. So think refrigeration, think heat pumps, things that are being scaled in the built environment today, but extending their capability to be able to directly boil water and deliver heat that is relevant for industry and for district steam and for large buildings. So yeah, I suppose the insight was go where no one else is, identify the white space, but making sure that it has that gigatons worth of impact to really motivate the need for a solution.
Yeah, we had Michael Sacchi from Dandelion Energy, and he commented on that as well, where they're putting geothermal for residentials homes, and they have a smaller machine now, so it can kind of get in there. But what was so interesting to hear was that they have a lineup of customers that they can't service yet because of the demand is so high, and they're already doing, within a couple of years, they're doing $50 million in revenue because the demand is so big. And he was like, yeah, there's just so many homes. We're only in like 2 states, and this can kind of expand across the United States and North America, and this is a great solution. But it's not sexy. There's drilling holes and putting in geothermal energy. But those hard problems that people need. So it sounds like that's kind of what you found. You found this like hard problem in this in this commercial setting, as in the boiler. So maybe just to paint a picture of like, what does a boiler look like inside a commercial setting, and like what type of industry would use this? My mind goes to obviously different processes, maybe breweries, maybe like who's your kind of customer that you kind of honed in on right away?
Yeah, so you're right. Steam is ubiquitous, right? One of the first things I thought about this problem when I saw steam decarbonization as an opportunity is we're never going to not need steam. Steam drove the Industrial Revolution. It is really what enabled the industrialization of manufacturing, and it continues to be the most ubiquitous working fluid in the world today. It's water. And so water is safe. We know how to control it. We've designed so much of the built environment and the manufacturing environment around it that we're not just going to walk away from steam. So what it really tells us is we need a solution for it. And so what do boilers do today? If you walk into a manufacturing facility, and the ones that I think I can use as an example now, because we'll talk a bit about our first customer in a bit, is New Belgium Brewery. If you walk into a brewery today, what do you really find? Okay, so you generally, if you're going on a beer tour, you're walking around the fermenters, you're smelling the grain boiling, you're smelling the hops and the floral. You see the fermenters. You might go down the bottling line and see, some sterilization occurring, and then bottles being filled, ready to be sent out. And all of that is done through steam. So what you don't see on that tour is the boiler room in the back, where you have 4 or 5 boilers sitting next to each other in parallel that are being turned on, ramped up depending on how much steam is demanded. All of the steam is being collected into one centralized distribution pipeline, and it's all of the steam is being collected into one distribution pipeline and being brought to being brought to the boil kettles, being brought to the bottling line. When in the brewing kettles, it is being used to directly drive the boiling of the water where the grain and the hops are. At the boiling line, it's being used for direct sterilization. And this is true across the food and beverage industry, but also all major industrial verticals, pulp and paper, food processing broadly, all these places where steam does cleaning, it does delivery of heat, and it's all done through a centralized approach in a boiler room. And then steam is brought through pipelines throughout the facility. But it's not just in the industrial industry, it's also in the built environment. So if you are on a college campus or a large corporate campus listening to this, there's very likely a centralized boiler facility that's generating heat and then piping it throughout all the buildings. Large buildings, large skyscrapers do the same approach as well. Steam is really kind of this ubiquitous approach where you can centralize the heat generation and then distribute it in a highly efficient way, all because of the special properties of water being safe and being a great working fluid for heat transfer.
And so similar to kind of like if you were to have a heating on the floor that was done, with water piping, I'm assuming it's almost kind of like a hot water tank essentially, where you're heating up that water and you're distributing it across. But the boiler rooms, which I completely understand what you mean by those are those boiler systems, and are they powered by, I'm assuming, some electricity for some electronics, I'm going to guess, and then the rest of it, is it typically done through natural gas because it's a pretty quick, efficient way to heat water?
Yeah, so steam is generated almost exclusively through fossil fuels today in industry. North America, Western Europe, you're using natural gas to drive steam generation. You're exactly right. You have a natural gas burner that is then being used to directly boil water. Southeast Asia and East Asia and other places where you don't have direct access to natural gas infrastructure, people are either using shipped in LNG, liquefied natural gas, which is more expensive than straight from the pipeline like we have in the US, and then or you're using fuel oil. But today in inland China, India, other industrializing areas, you're still using coal stoker boilers. Essentially, think back to like the 1800s, the early part of the Industrial Revolution, where people are shoveling coal into boilers. It's not that far from that anymore. So where we're sitting in the U.S. and where in a brewery or in a food processing facility in North America today, you're going to find a gas boiler. It's tied to the natural gas distribution pipeline, and it's burning natural gas directly. There's really very little electrical consumption being used today, but we are focused on electrifying the boiler room to get rid of the on-site combustion, the fossil fuel combustion that's being done, and electrify it in a cost-effective way. And our technology to do that is essentially replacing the burner, the fossil fuel burner, with a heat pump. So just like some of you may have a heat pump heating your home, taking heat from the ambient air, using electricity to upgrade that heat to, say, warm your house. So that might be done around 30, Celsius or something like that if you like it warm. We are going all the way up to 150 Celsius to directly boil water. So we're extending the capabilities of what heat pumps can do to go all the way from ambient up to steam temperatures, and replacing the flame with an electrified solution that is highly efficient.
And before you decided to build this, were there all electric options? Like, I'm trying to think about like an electric kettle type of idea where, that's probably pretty inefficient. And that's why they probably choose to use natural gas from both efficiency and cost. But were there electric options for boilers? Are there electric options for boilers?
There are. electric options today. And actually, it's worth thinking about what are the decarbonized options for a manufacturer today, or somebody who has a boiler and they want to replace it. There's kind of two paths you can take to decarbonize heat. Number one, you can do fuel switching. So, okay, I want to move away from the fossil fuel to something that is a clean fuel, maybe hydrogen or renewable natural gas. So that is one path. You can use your existing boiler, keep your natural gas boiler on site, but put RNG in there. The challenge with that is it's extremely limited. So some manufacturers will use RNG today, but even if we were to develop all of our sources, potential sources of RNG, you can only replace about 11% of total natural gas usage. It's really something that's not very feasible, and it's very expensive. Usually represents a 4 to 20 time increase in cost of fuel for making steam. Now, the other approach is to electrify. And so today there are products available on the market that are resistive boilers, exactly like you envision, this idea like an electric kettle, where you are resistively heating the water. So think of a resistive element like an old electric stovetop where it gets hot and orange, but that's directly in the water, kind of an immersive heat immersion heater directly in the water and boiling water. That means you're paying electricity prices for your steam. And again, that means a pretty big step up in cost compared to a combustion approach. So by using a heat pump, we are able to generate that same amount of steam in an electrified approach that uses half the electricity of a resistive boiler. So by limiting the amount of electricity that's being used to generate the same amount of steam, we make it cost effective. We make the lowest cost solution to decarbonize the boiler as a drop-in approach today. So it was really about looking at a product need. As somebody who spent a lot of my early career on early stage technology development, both in the lab at MIT, but also investing in it from the Department of Energy, from ARPA-E, this was a very different approach for me, which was really exhilarating to focus on a product need and going out and identifying the technology to enable it, heat pump technology, rather than starting with a technology, kind of starting with a hammer and looking for a nail. That's a much harder entrepreneurial path to go. Here is really, how can we go make this be driven by unit economics, really driven solution based on going out and finding the technology that enables the product.
Yeah, and I guess two questions there. So one, it sounds like you're using a lot of what is existing, but it sounds also like the innovation maybe came from on the heat pump side. And maybe like I'm pretty naive. From a residential perspective, I know that like heat pumps, and I'm in Canada, so I'm talking in Celsius, so bear with me. But I know that they can deal with X amount of heat, and they can also deal with X amount of external cold temperatures. That's a residential type of heat pump. But when it comes to commercial, you're talking about, I think you said like 150 degrees Celsius. That's obviously absurd when it comes to a residential side of things. But was any of that technology there for heat pumps in a commercial setting, or was that something that you had to work towards developing?
Yeah, so that's something we've worked towards developing. There have been heat pump technology that could deliver very high temperatures, but generally you can't do it directly from ambient air. So if you want to generate steam temperatures at high temperatures, you need an input source of heat that's not cold outside temperatures, but you'd need a constant source of input, say at 90 Celsius or something like that. So very few facilities have that sort of waste heat available. And even if they do, it's a very complex project to shut down manufacturing, capture all that waste heat, install the additional heat exchangers and collection systems required. It becomes very capital intensive and very hard to justify doing a reasonable payback period on that. So the innovation we have focused on is a heat pump technology that can bridge all the way from the coldest cold. So, I appreciate you being a Canadian here. I'm very comfortable speaking in Celsius on this problem. It turns out once you become a PhD engineer, you really become more of a Celsius person. My brother makes fun of me all the time. He's a real process engineer in the US, and he's always like, what is that in Fahrenheit? And I'd say, I don't know. But, we were able to go all the way from that negative 20 Celsius day all the way up to 150 Celsius steam. And that's all about offering the manufacturer the capability to achieve decarbonization. You need to be able to have a technology that is delivering steam at what is demanded. Essentially, the processes that it drives dictates the temperature of steam you need. And you can't just go in and say, oh, my boiler is only limited to 120 Celsius. No, you got to be able to get up to the temperatures that they require. So we focused on the technology development and the innovation in the heat pump cycle necessary to deliver that.
Every week on Someone Like You, we dive into stimulating conversations with founders, entrepreneurs, business owners, and the likes who are consciously and successfully creating sustainable business solutions for the long haul. Tune in every week for a new inspiring conversation on leading climate solutions. And if you're enjoying the podcast, please share it. And also, don't forget, subscribe on the platform of your choice and give us a rating and a review. So all of this obviously sounds, it's obviously very complex. And so how did you go from idea to building this first prototype or model to work with a potential customer in terms of funding all of this? This obviously involves, a space to do it, and I'm sure equipment to bring in and people to do it. Did you go the traditional, the VC path? Was there grants? What was your path to funding all of this?
Yeah. So, the genesis story of AtmosZero is pretty interesting. And so let me or kind of the founding story will tell all of this. So when I came up with the idea of this solution, I still have it memorialized in an email I sent to my future co-founder, Todd Bandauer, who is a professor at Colorado State University. This was in the middle of the pandemic. I shot him a note in early 2021 saying, hey, if you think we could put together an air source steam heat pump that is capable of delivering steam in this kind of cost-effective way, an electrified solution, I'd quit my job and start a company with you. Now, I've known Todd for a number of years before that. He was a person I funded when I was at the Department of Energy. I saw him go from concept to industrial scale prototype at his lab at Colorado State. I knew that he had the facilities, the capability, and the access to the ecosystem of a team that he could muster to drive the technology development on this. And so, he was essentially my handpicked CTO for this. And that put me in the CEO position, which I had to get smart quickly on what does it mean to go out and raise money for a hardware solution like this. And so, what we did first was really make sure we had a there, not in terms just of a technological solution, but also in terms of a business. There's no sense in developing this technology through a startup and raising venture capital to do that if you don't have a line of sight opportunity to have a venture scaled solution. And so we spent the summer of 2021 on Zoom calls like so many of us. It was a nice escape from the rest of existence at the time, was to talk about steam, talk about boilers, talk about manufacturing processes that we could get to a cost down, scalable solution for this. And we got to that point towards the end of the summer where we had shot every hole in our concept that we could, and it was still standing. And so we knew we had a there. We, along the way during the summer, brought in our third co-founder, Ashwin Salvi, who hired me at ARPA-E years before, but is really what I would say is like highly complimentary to myself and Todd, because he really understands what it means to do business development and B2B sales in OEM hardware. He, after his time at DOE, spent a number of years working in automotive manufacturing and innovation. And, we came together and really saw a path forward, and we ended up, our first money in was venture money. We raised a seed round that we closed in early 2022, kicked off the company May 1st of 2022, and have grown it now to a team of 17. We've won some grants along the way, raised additional capital along the way, and are acquiring company customers. And we recently came out of stealth this summer to announce our first customer, our first pilot project at New Belgium Brewery. As I discussed before, we're going to be proving the concept of drop-in replacement of one of their gas boilers on site next year. Help them to become the first net zero brewery in the world.
And so when you think about this kind of segment or customer market, obviously we're talking, I'm assuming it's fairly massive, but I'm also thinking that it's also it's a market where boilers probably need to be there. I'm sure they have to be maintained, and I know sometimes they have mechanical engineers that are in staff that just take care of boilers in places. But how long do traditional boilers last? And so is this kind of this market where once you kind of prove out with your first kind of customers that this works, this is saving money, it's reducing obviously the amount of emissions, is it now a get in front of all those people that are starting to look through that next, what are we going to replace this with?
The average age of a boiler in the field today is about 40 years old. So these are long-lived pieces of equipment, and we are designing to focus on being a long-lived piece of equipment. What's interesting about the industrial market compared to, say, the residential market is that you have much more sophisticated customers who are very on top of their preventative maintenance schedules. So yes, with any boiler technology, with any industrial equipment technology, you need to plan ahead and have either annual or biannual shutdowns where you go in, you clean out heat exchangers, you check the health and life of pumps, compressors, bearings, moving parts, and plan ahead for doing swap-ins and replacements. So, that is an important part of the industrial ecosystem. And one of the things that we have thought about from day one, by focus on a productized solution rather than a bespoke solution, we plan ahead to be able to have, common parts, spare parts ready for easy integration into a preventative maintenance schedule, that we are deploying a system that is going to be as long-lived as today's combustion boilers.
Yeah, and I'm sure that's an important piece. So, like when you worked with New Belgium Brewing, I understand that they have like you said, they want to be the first brewery to be climate neutral. I think they have a goal of 2030 to do that. They're obviously highly engaged. I think they're also I think they're based in Colorado. Is that, or no? They're not based in Colorado. They are based in Colorado. Okay.
They are based So New Belgium is based 4 blocks away from us in Fort Collins, Colorado. And what's really nice is we've been customers of theirs long before they came customers of ours. They're an incredible brewery. We need to pay down our beer tab.
And so this is going to be installed, and from there, this is going to be, kind of your quote unquote, like kind of case study that this works. How long, or I guess, do you have other customers that you are going to be working with in this kind of test phase? And how long would it take you to feel confident, or how long will it take New Belgium to feel confident that this works? Like, is this like, a 6 months of testing? Is it a year of testing? Like, how long before, you can kind of confidently say that, let's really, raise this next round. Now it's time to get as many boilers as possible into industrial situations.
Yeah, so you're talking a bit about the chicken and the egg problem that exists in hardware commercialization. And I'll use this situation as an example, but we can talk about it a little bit more as how we've approached it. In order to get customers comfortable with a hardware solution, it's all about hours online. You get up into the thousands of hours, you've kind of proved your long-term viability. But in order to get thousands of hours, you literally need to run for thousands of hours. And, you put that against, kind of the timetables of what does it mean to be venture scalable, it becomes difficult without parallelization. So we've focused on being able to prove relevant technology de-risk milestones from day one. One of the reasons we chose Fort Collins to build this company to spin into Colorado State University is because our prototype in the lab is at our first product scale. It is the same size as our first product that we'll be piloting at New Belgium. So we're able to do a lot of, representative testing right now in our lab facility that is starting to really prove those hours of generating steam, of running our custom compressors, of being able to run the demand cycles for generating and delivering steam. Now, with a customer, it's obviously you look at what New Belgium we're doing with them is we're doing a 6-month in-field test in their facility of this pilot to be able to prove that it can drop in, swap out, and replace one of their gas boilers that are on site. And so by going in and replacing one of those gas boilers for that time period is kind of the stage gate by which we are working with them to then plan upon, once they feel comfortable that it's worked that time, is then to scale out the solution across all 4 of their North America breweries. So they also have breweries in Asheville, North Carolina. In Comstock, Michigan is where Bell's Brewery is that they own. They also have a new brewery in Daleville, Virginia. But they're also owned by Kirin. And Kirin, based in Japan, owns assets around the world. So there's a really big desire among the company to be able to find something like our solution, which has one spec, one design, one product, that can then be deployed in all the other breweries without any special, complex integration project, no bespoke engineering. Essentially be able to prove it in one location and deploy it everywhere. And that's exactly kind of the partnership and why we're so focused on technical de-risking as quickly as possible so we can help them meet their timelines. There's a lot of companies like them who are trying to hit these milestones, and 2030 is not that far away when you talk about hardware timelines. And so we want to make sure we have something scaled and on the market that helps these our customers achieve these goals.
And I guess that leads to me that kind of like the marketing and sales side of your business. Like, I'm assuming it's probably not super traditional that like an AtmosZero is speaking with New Belgium about putting in a boiler. Or maybe I'm wrong. Like, how do most boiler companies get service in the industrial? Like, how do they get installed? Is it through, service-based companies that then use technology that's built by, Trane kind of comes to mind. I think that's there's a heat pump company and a furnace boiler type company. Or like, how do you go to market? Is it just the technology and you're the supplier, or do you want to work? You obviously right now you want to work directly because you want as much feedback as you can. But what is, I guess, the go-to-market strategy to get more AtmosZero technology into industrial? Is it through service companies that are putting these actually in?
Yeah, so I think you are highlighting a great point. Industrial boilers are kind of the OG of B2B sales. They have been the key piece of capital equipment that has driven industrial manufacturing since the 1860s when Babcock and Wilcox packaged the combustion boiler. And these, therefore, have really an established distribution model. Generally, individual manufacturers have their preferred engineering and procurement companies, EPCs, that they trust to do capital work inside of their facilities. And also there are national EPCs that will integrate and help to support these things. So boiler distributors are going to be certainly one of our long-term partnerships that are going to be very important. But there is also potential opportunity to directly disrupt that. We're offering a highly differentiated solution here, and we have a lot of customers who are reaching out to us directly. However, it will require third-party specialists, engineering specialists that install these steam systems in kind of a traditional approach to steam system management that we want to be able to integrate into those distribution pathways. However, one of the key things is, absolutely right that goes back to the not so sexy of a solution kind of thing. This is not like EVs, right? We're not selling directly to customers. You're not likely to see an AtmosZero commercial at the Super Bowl unless, maybe we happen to partner with AB InBev and Budweiser or something like that.
Hey, you never know that maybe New Belgium would do it with you. Obviously, thinking about, we kind of touched on what's next over the next kind of 3 to 5 years. But when you think about that question, what's your kind of your focus? Obviously, you're focusing on this technology, you're focusing on these timelines. But what do you think about when you really think about this kind of longer term view and where you want to be with AtmosZero?
I mean, it's not every day that you could go out and unironically tell the world that you're trying to build a billion-dollar boiler company. But that's exactly the path that we're on. And what we see right now in front of us in the next couple of years is moving as quickly as we can to a fully productized form. Think, when I say productized, I mean fully packaged. It's ready for mass manufacturing and ready for us to scale and deliver the gigawatts worth of demand we have in our pipeline today from customers looking for solutions by 2030. It takes a lot of work in hardware to get there. You can't move fast and break things in the traditional, software model. What we think about right now is how we move fast and build things, and doing that in a way that can, prove to the market that this is a resilient solution that is capable of being cost down effectively through mass manufacturing. And that's what we're just focused on, is how do we move as quickly as humanly possible to get this product into the market to the customers who want it yesterday.
When you think, or when somebody asks you, an entrepreneur or a budding entrepreneur or somebody, and you're, the statement of building $1 billion boiler company, what would you say as advice to kind of an entrepreneur that's thinking about getting into climate solutions, a sustainability focus, like addressing this problem, obviously head on, either in a sexy or a non-sexy industry? What type of advice would you say to them?
I think a lot of what I would say is maybe not necessarily to the young entrepreneur, but maybe somebody who has not done entrepreneurship, who's gained a lot of skill. One of the things I'll say is I'm 39 years old. I'm going to be turning 40 in a month. And, maybe like not your traditional startup founder from like a Silicon Valley, kind of approach. The average age in our company is probably a decade older than, or maybe even more than, a lot of Bay Area kind of companies. And that's, partially a function of where we are in Northern Colorado, hiring talent that has, accumulated years of experience. But it's all about what you're trying to solve and recognizing what are you uniquely positioned to do and how do you accumulate the team around you to be able to do that. When I think about where I am today as an entrepreneur, I am kind of a accumulation of my experience. And in order to decarbonize boilers, to build a $1 billion boiler company, it's about bringing together technology innovation, understanding the policy environment that's going to accelerate the deployments, and the business fundamentals that make it all come together. And those are things that I know when I look at myself a decade ago on the eve of turning 30, I certainly wasn't ready to do. So, I think there's a little bit of advice that I would give is go out and get the experience you need to build the company you want to build.
Well, thanks again for joining us. I love this conversation because it's such a massive market that is needed to be disrupted. But I think what people need to realize too is that it's a market that already exists. It's not like you said. There's distribution partners there. People are buying this. They've been buying it for many, many, many years. And these type of markets are hard to break into. But when you do, they're big and they need these type of change. So thanks again for joining us. And this is Addison Sark from AtmosZero.
This was great. Super fun. Thanks, Marco.
I hope you've enjoyed today's episode of Someone Like You. We're a new podcast, and I would love if you can do a few things. One, please share the podcast with a friend, a family member, a work colleague, anybody that you can think of that would enjoy learning more about these incredible brands. Please also support these type of companies. They're doing the hard thing, and the hard thing often takes a lot of people to get on board. And don't forget, please subscribe on the platform of your choice and give us a rating and review. I'm Marco Pimentel. Thank you for joining us today. For more information on Someone Like You, you can find us on Instagram at Someone Like You Podcast, with all the links to the podcast, our website, and more information about the brands that we feature. Thank you again.